Finally, we're going to get to pick apart the PHP script that uses the Unix dialog program. The first line here is the shebang, which tells the command line to interpret this script when it's executing it using the PHP CLI interpreter. Then we have the opening PHP tags, and the closing PHP tags are not necessary, so we just have the opening PHP tag. Next, these four variables are initialized. Pipes is an empty array, process is null, output is an empty string, and return is the integer -1. Next, we have a function declaration. This function is called process start, and it takes two parameters. The first one is a command. The second is a variable called want_input_fd. fd is file descriptor. So this variable is for determining whether the code which calls this function wants an input file descriptor or not, and the default is false. From the comment section here, we can tell that command is going to be a string, want_input_fd is a boolean, and it determines whether or not input fd pipe is required, and the function does not return anything. A doc block is what they call this comment section. Down here, inside the function, process and pipes are declared as global. Pipes is an array, and process is just a regular variable. By declaring these two variables global, whatever happens to them during a function call will be reflected in the scope of the script. I fleshed this thing out a little bit. I added comments. I added some variables. Basically, I tried to make it look as much as possible as the example on php.net, which is this right here, this example. So, pipes is an indexed array of file pointers that correspond to PHP's end of any pipes that are created. Alright, pipes is passed in by reference, okay? This is going to be like pipes 0, pipes 1, pipes 2, pipes 3. These are going to be the resources that our script will be able to use in order to write to or read from the child process. Okay, process equals null. This is a resource representing the child process. Okay, and remember, pipes and process are the only things returned by the function process start. So process is going to be the resource representing the child process, and this resource is going to be closed using proc close. I don't know why that's missing. Before I take a look at the descriptor spec in our example, which is this descriptor spec, I want to take a look at the one I'm already familiar with, which is the one on php.net. Okay, so the descriptor spec has an array. That array describes what each file descriptor will be for with respect to the child process. So in this example, file descriptor 0 is a pipe that the child will read from. File descriptor 1 is a pipe that the child will write to. File descriptor 2 is a pipe of type file whose location is this. And this is a pipe that the child will write to. So this is what the php.net example is like. Next, we'll look at this one, which is the one we have. In our example, the 0 file descriptor for the child process will be a pipe that the child reads on if want input fd is true. If want input file descriptor is false, then the child will get its input from standard in. For file descriptor 1 for the child, that will be standard out, and this is a resource, and it's a predefined constant in PHP. A resource is an object, and this type of resource can be for a file or a process, and it's declared either for reading or writing. It can't be both reading and writing. Okay? And as you may recall, each one of these can be assigned an array or a resource. std in, std out are resources. Array pipe r is an array. Now file descriptor 2 is going to be a pipe which the child writes to. File descriptor 3 is also going to be a pipe which the child writes to. And in our particular example, the child process that we will use in our script will be writing errors to 2, and it'll write output to 3, and it will also have an output which is going to standard out, which is usually the terminal window, but that can be reassigned. It all depends on the bash environment, what it is assigning standard out to. CWD is set to null. CWD stands for current working directory, the initial working directory for the command. And this must be an absolute directory path or null, which is what I set it to, if you want to use the default value, which is the working directory of the current PHP process. In other words, I believe that means the parent script's current working directory. $env, that allows you to set any environment variables for the bash environment that the child process is going to be executed or run in. And here I set it to some dummy variable. We could set it to null. I just, this script is meant to be as an example for me to use in the future, so I didn't want to just set it to null. I want to see actually what a value would look like, and it would be an array, and each element of the array would have a key and value. Now, okay, so we actually run the process open function right here, and we assign its return value to $process. That return value, it's going to be a resource representing the child process, which should be freed using process close when you are finished with it, or upon failure, the return value is false. So process is either going to be false or a resource that points to the child process. And the format or the class which this object belongs to is the type that process close would accept as an argument. Now, we just did process start function. Here, there's the definition for process stop. Process stop doesn't return anything either. However, process and pipes are still globals here, and there's also return and output. I assume return is the return status of the command or the child process that was called, and output is going to hold the text output which the child process produced or which the command produced. Remember, we're doing this to run a Unix command from within a PHP script. That's why I call it command. So what is process stop actually doing? If pipes 0 is set, okay, and notice it's going to do this for each one of the pipes, and there's going to be pipe 0, pipe 3, pipe 2, 0, 3, and 2. I don't see a pipe 1. I'm not sure why. So what are these pipes? Oh yeah, 1 is standard out, okay? So remember, that's why it's saying if pipe 0 is set, because that could possibly be set, or maybe it isn't set, depending on the value of want input fd, okay? Yeah. See, if want input fd is true, then it's set to a pipe. Otherwise, it's set to standard in. So that's, if it's set to standard in, right here, then there won't be a pipe with the index 0. Okay? So if pipe with index 0 is set, then close it and sleep for 2000 microseconds. Okay? Now output, we're going to assemble the output. Here, there's a loop that uses fgetS, and what fgetS does is it reads a line, including the new line character. Okay, and then it adds that to $output, and it keeps going until all the output from pipe 3 has been read. And remember, pipe 3 is the output of our child process. See, pipeline to which child will write any output. Now, from what I understand, dialog, and I don't know if this example is meant to run just dialog as a child process, or it's meant to be able to run any command as a child process. But from what I know, dialog, its output goes to file descriptor number 2. It doesn't go to file descriptor number 3. Anyways, I'll worry about that later. So output gets collected in the variable called $output. Errors, okay, it seems what's happening here is the loop is reading from pipes 2, which is for the errors coming out of the child process. But the variable errors is not going to contain the errors that are being spit out. the errors being spit out are actually being written to standard error. Now, I'm not sure exactly why. Okay, let me take a look up here. Yeah. Okay, the errors are written to a regular pipe. Okay, so we are taking that regular pipe. See, we are taking that regular pipe and we are sending what comes from it to standard error. Now, standard in, standard out. I'm not sure why we didn't just specify standard error here and not have to deal with this, but there may be a reason, because maybe this way the code can be modified and we can send the errors somewhere else this way. And I don't know why errors is being incremented. Okay, yeah, that way, if there are errors, then you're going to write to standard error another line. This time, this line is coming from us, whereas the errors that were going to standard error before were coming from the errors coming from the command or the child process. So this will be actually something that we get to write to the error, to standard error. And it's going to say dialog output, the buffer. Dialog, I believe, is the name of the child process. Here he's actually explicitly saying which command we're going to be using for the child process. And I believe this should be changed to a variable. That way we can use this script for any child process, not just for dialog, for any command, Unix command. Here he says dialog output the above errors giving up. Okay, and then he puts exit 1, which terminates our script. Okay, and then here he closes pipe 2 and pipe 3, and he has a loop where there's a sleep of 2000 microseconds, and then the variable status. Let's see, do we have that variable anywhere up here? No, this is a new variable. To be continued.